Hello everyone. Welcome. Assalamu alaikum. Konnichiwa. Guten Tag. Dobrodan. Just waiting for everybody to join. If you're here for the first time, welcome. We are looking at 12 exam questions on product rule for counting. The first question paper is from paper 3, June 2018. Pause the video and have a go. When you're done, or if you're stuck, or you want to work through it with me, press play. Okay, the first question. There are 16 hockey teams in a league. Each team played 2 matches against each of the other teams. Work out the total number of matches played. So we have 16 hockey teams. Each team played 2 matches against each of the other teams. Work out the total number of matches played. So if you think about it, for the first one, we've got 16 hockey teams, and they're going to be playing each of the other teams. So you can't play yourself, so you're going to have 15 teams altogether. And so you have 16 times 15 is your working out. And so paper 3, we are allowed a calculator. Get your calculator out and put 16 times 15 gives you 240. And that's my answer, 240. This is an analysis of product rule for counting, and this is for the higher GCSE paper. You can see it occurs on paper 1, it occurs paper 2, and paper 3. So it's both non-calculator and calculator. And I've looked at 12 exam sets, and of each of the 12, it's occurred every single time. Here is the second question of our pack. So this is question 2 of 12. This is from paper 3, again, June 2022. Press pause and have a go. When you are ready, press play for the answer, or if you are stuck or you want to work it through with me, press play. So here is the next question. Raheem has 16 shirts, 5 pairs of jeans, 3 jackets. Raheem chooses an outfit to wear. An outfit is 1 shirt, 1 pair of jeans, and 1 jacket. Work out how many different outfits Raheem can choose. So we have 16 shirts. We've got 5 jeans and 3 jackets. And the outfit is 1 shirt, 1 pair of jeans, and 1 jacket. And so what we're going to be doing is we're going to be looking for the shirt, 1 shirt. We're going to be looking for a jean, and we're going to be looking for a jacket. So let's put J-E-N for jeans and jacket. We have that. And so product rule, product means we're going to be multiplying. So we're going to be multiplying all of these. How many shirts? 16. How many jeans? 5. How many jackets? 3. And again, this is paper 3, so we are allowed to use a calculator. So we can put this into our calculator. 16 times by 5 times by 3 gives me 240. Okay. And usually for this working out method is a method mark, and for this is your accuracy mark. So that's our 2 marks. Let's go to the next question. This is our third question of 12. Okay, press pause and have a go. This is worth 2 marks. All right, so if you're ready or you're stuck or you want to go through it with me, question 13. In a school, there are 16 teachers and 220 students. Of these students, 120 are girls and 100 are boys. One teacher, one girl, and one boy are going to be chosen to represent the school. Work out the number of different ways there are to choose one teacher, one girl, and one boy. So if we highlight the key information, we've got there are 16 teachers, 220 students, 120 are girls, 100 are boys. One teacher, one girl, and boy are going to be chosen to represent the school. One teacher, girl, boy. Work out the total number of different ways there are to choose one teacher, one girl, and one boy. And so if we look at it, how many teachers do we have? How many girls do we have? How many boys do we have? We've got 16 teachers. How many girls do we have? 120 girls. And how many boys do we have? 100 boys. And so again, similar to before, we just multiply this out. So this is paper 2 again. Paper 2, we are allowed a calculator. So 16 times 120 times by 100. That gives us 192,000. So 192,000. Okay, and a similar thing to before. If you have this working out, it's a method mark. And this is an accuracy mark. So 2 marks for that question. Well done if you got that correct. Let's go to our next question. And just to kind of give you a little quote, this is from Nelson Mandela. The greatest glory in living lies not in never falling, but in rising every time we fall. And maths is a very good example because we always are trying problems, especially hard ones, and we may not be able to work it out at the first attempt or even the second or the third. But as long as we don't give up, we will eventually rise to the challenge. And hopefully by the end of today's session, you should be able to answer questions on product rule for counting. Right, this is our 4th question. And this is from paper 3. Again, calculator paper from June 2017. And we're answering question 11. And it's worth 2 marks. Press pause and have a go. When you're ready, press play for the answer. Or if you want to follow me, let's go. And so this question is saying, Jeff is choosing a shrub and a rose tree for his garden. At the garden center, there are 17 different types of shrubs and some rose trees. Jeff says there are 215 different ways to choose one shrub and one rose tree. Could Jeff be correct? You must show how you get your answer. And notice this question is slightly different from before because it's saying there are 215 different ways to choose one shrub and one rose tree. So in this question, we're actually being given the answer. So Jeff is going to choose a shrub and a rose tree. There are 17 different types of shrubs and some rose trees. Jeff says there are 215 different ways to choose one shrub and one rose tree. So what we're going to do is, I like to ignore all of this. What we are looking for are shrubs and we're looking for rose trees. And product rule for counting, we multiply them. And we are told there are 215 different ways. And so there are 17 different types of shrubs. So that's 17. And some rose trees. We don't know what the rose trees are. So this is an unknown. And so we can represent it with an unknown x. And so if I'm going forwards, I'm multiplying. If I want to find out what x is, I'm going backwards. So opposite of multiplying is dividing. So I'm going to be dividing by 17, dividing by 17. And it's paper 3, so calculator is allowed. So I'm going to do 215 divided by 17. That should give me the answer. And so if I do 215 divided by 17 equals 12.64, and it carries on. So I'm going to write here 12.64 dot dot dot. And it says, could Jeff be correct? If Jeff was correct, this would be a whole number. So this is not a whole number. So this is not a whole number. And so therefore Jeff is wrong. Therefore Jeff is wrong. Okay, and so having this working out is a process mark. And then we have a communication mark for explaining our answer. So those are the 2 marks. So hopefully you got that correct. And the mark scheme will say you have to say no with your answer. So that's important. If you don't have that, you don't get the full marks for that question. Let's go to question number 5 of 12. So question number 5. This is from paper 1. That's non-calculator from June 2023. Press pause and have a go. When you're ready, press play for the answer. Or if you're stuck, then you can also press play. Let's go through this one. The menu in a restaurant has starters, main courses, and desserts. There are 5 starters, 12 main courses, X desserts. There are 420 different ways to choose 1 starter, 1 main course, and 1 dessert. Work out the value of X. So you can see we have 5 starters, 12 mains. We don't know what X is, but we are told there are 420 different ways. So you can see we have to choose 1 starter, main, and a dessert. And you can see, similar to the last question, we're kind of told, we're given the answer. So we have a starter, a main course, and a dessert. And that equals to 420. And so how do we work this out? How many starters do we have? 5. Main course is 12. Dessert is X. And so we have to work that out. So now I can do 5 times 12. That gives me 60. 60x equals to 420. And now I can simplify. Opposite of multiplying is dividing. So I divide by 60. Divide by 60 on both sides. So I'm going to have x equals to 420 divided by 60. It's non-calculator. So how do I work this out? Oops, something's happened. My lighting, whoopsie-daisy. There we have it. Okay, and so we can do 420 divided by 60. How do we do this without a calculator? So the zeros will cancel each other out. 6 divided by 40, 42 divided by 6 rather. My 6 times table, 6 times 6 is 36. So x equals to, and then 36 plus 6 is 7, so it's 7. So x equals to 7. So that is my final answer. And so with this one, we have a process mark here again. So having something like this, you have a process mark, and then we have an accuracy mark for your final answer. So hopefully you got that right. Well done if you got that right. Let's go to the next question. And if you are here for the first time, remember to subscribe. You will get videos and masterclasses on different topics. This is the next question. This is paper 2, November 2019. This is question 6 of our pack. And paper 2, so it is a calculator paper. Press pause and have a go. Hopefully you're getting the rhythm of these questions. You can see there's a pattern happening, and so you're getting them correct. Okay, we're going to make a start on the next question. Question number 14. So for our 6th question, Sadia is going to buy a new car. For the car, she can choose one body color, one roof color, and one wheel type. She can choose from 19 different body colors, 25 different wheel types. The total number of ways Sadia can choose the body color and the roof color and the wheel type is 3,325. Work out the number of different roof colors that Sadia can choose from. Okay, so what is the key information here? So she's going to buy a new car. We don't really need that sentence. We can cross that out. For the car, she can choose one body color, one roof color, and one wheel type. We've got 19 different body colors, 25 wheel types, and total number of ways is 3325. So we have to work out the different number of roof colors. And so similar to before, the previous questions, we are told that, I didn't highlight this, which is one body color, roof color, and wheel type. So we've got body color multiplied by our roof color multiplied by our wheel type. So we've got 3 different things here, is equal to 3325. So what's our body? 19. Body colors are 19. R, we don't know what R is, but we are told there are 25 wheel. If we don't know what R is, that becomes an unknown. And so now we can work this out. 19 times 25, get our calculator out. 19 times 25 gives us 475. X equals to 3325. We want to work this out. What's the opposite of multiplying? We divide by 475. Divide by 475. X equals to 3325 divided by 475 gives us 7. And so similar to the previous questions, if you have something like this, you have a method mark, and then your final answer is an accuracy mark. Okay. The next question, this is our 7th question. This is paper 2. So again, calculator from June 2020. And we're going to scroll down to the bottom of the paper, and you can see our question here. It's worth 2 marks again. Press pause and have a go. When you're ready, press play. Or when you're stuck, press play. Or if you're just waiting for me to go through the answer, let's go through it. Bismillah. Right, Jack is in a restaurant. There are 5 starters, 8 main courses, and some desserts on the menu. Jack is going to choose 1 starter, 1 main course, and 1 dessert. He says there are 240 ways that he can choose his starter, his main course, and his dessert. Could Jack be correct? you must show how you get your answer. And so if we highlight the keywords again, we've got 5 starters, main course, and desserts. So we're not told what the desserts are. Jack is going to choose 1 starter, 1 main course, and 1 dessert. There are 240 ways he can choose that. Could Jack be correct? Okay, and there's a question mark, so we need to be careful. That's probably a communication mark. So we've got 1 starter, 1 main course, and 1 dessert. So we are going to be multiplying them all. And we are told Jack is going to choose, he says there are 240 ways. So what that means is when I multiply these numbers, they should equal to that. If they don't equal to that, then obviously that's not correct. So I'm looking for whole numbers. So 5 starters, 8 main course, and we don't know what the dessert is, X. So you can see this is very similar to the previous questions. 5 times 8, even though it's a calculator paper, I don't need to use a calculator. That's 40 times X equals to 240. And then opposite of multiply is divide. So I'm going to divide by 40. And so X equals 2. And here, this is where I can use my calculator. 240 divided by 40 gives me 6. And 6 is a whole number. And so I need to make sure I answer my question. Could Jack be correct? And the answer is yes. Jack could be correct. And similar to before, this is working out mark here. So this is a process mark for this year. And we have a communication mark for saying yes, we've answered the question. All right, hopefully you got that right as well. Well done if you did. Let's go to our next question. This is our 8th from 12. And this question is also worth 2 marks. Press pause and have a go. When you're ready, press play for the answer. Okay, question 15. A pet shop has 7 guppy fish, 13 tetra fish, and 5 angelfish. David is going to choose one of the following combinations of fish: a guppy fish and an angelfish, or a tetra fish and an angelfish, or a guppy fish, a tetra fish, and an angelfish. Show that there are 555 different ways for David to choose his fish. So if I look at my key information, I've got 7 guppy fish, 13 tetra fish, 5 angelfish. We've got different information here. We've got guppy fish, angelfish, or a tetra fish, angelfish, or a guppy fish, tetra fish, and an angel. And we have to show there are 555 different ways. So this question is significantly different from the previous questions. Now, in terms of what do, we do exactly or very similar to what we've done before. So we are going to be following this order of working out. And it's also given us the answer. So we just need to try and show that it equals to 555. So if I go through this, I'm choosing a guppy fish and an angelfish. So I've got a guppy fish, an angelfish, tetra fish and an angelfish, tetra and an angel. I've got guppy, tetra, and angel. Guppy, tetra, and angel. Okay, and I have to show this, so I have to kind of add all of these combinations up. So I'm going to be multiplying and then at the end adding them up. So how many guppy fish do I have? Guppy fish is 7 times by angelfish is 5. I'm going to have tetra and angel. Tetra is 13. and Angel is 5. And then I'm going to have Guppy, Tetra, and Fish. So Guppy is 7, Tetra is 13, and then Angel is 5. Put this into my calculator. 7 times 5 is 35. I don't need to work that out. 13 times 5 gives me 65. And then 7 times 13 times 5 is 455. And so when I add these together, 455 plus 65 plus 35 should give me 555. And hey ho, it does. 555. So slightly different, but it's actually very, very similar to what we've been doing. So you can see the questions are now getting harder. So well done if you got that correct. And where are the method marks? So the working out, as long as you've got this method working out, that's a method mark. And for the final answer, those are your 2 marks. Okay, let's go to the next question. This is paper 2. This is our 9th question, paper 2, November 2018. And now you know the drill. Press pause, have a go. When you're ready or you're stuck, press play. Question 11. In a restaurant, there are 9 starter dishes, 15 main dishes, 8 dessert dishes. Janet is going to choose one of the following combinations for her meal. A starter dish, a main dish, or a main dish and a dessert dish, or a starter dish, a main dish, and a dessert dish. Show that there are 1,335 different ways to choose the meal. And let's highlight our key information. We've got 9 starters, 15 mains, 8 desserts. We've got to go for starter and a main, or a main and a dessert, or a starter, main, and a dessert. And we have to show there are 1,335 different ways. So you can see this question is very, very similar to the last question that we've just done. So we've got starter and main, starter and main. We've got main or dessert. We've got starter, main, dessert. So we've got starter, main, and a dessert. And like before, we add them all together, and that should give us 1,335. So how many starters? We've got 9. Oops, 9 times mains is 15. My main is 15 again, times by desserts are 8. Starter is 9. My main is 15. And my dessert is 9. 8, sorry. Why am I saying 8? My desserts is 8, so we've got that. And this is paper 2, so we are allowed a calculator. 9 times 15, 135. 15 times 8, 120. 9 times 15 times 8, 1080. And we add these all together. That should give us 1,335. Okay, and again, similar to before, our working out is here. On this occasion, there are 2 method marks. So this question is actually worth 3 marks. So 1 mark is for a correct procedure. So as long as we've got the correct procedure, so something like this, that's a method mark. So if you get 135, for example, then for this process is another method mark. And then for the last bit is our accuracy mark or communication mark. All right, so hopefully you got that correct. Question 10 of 12. So we're getting to the end of our lesson on product rule for counting. Press pause, have a go, and when you're ready, press play for the answer. This is paper May 20, paper 1, May, it says May 1, should say paper 1. Paper 1, oops, paper 1. And this is from May 2019. So there are 3 dials on a combination lock. Each dial can be set to one of the numbers 1, 2, 3, 4, 5. The 3-digit number 553 is one way the dials can be set, as shown in the diagram. A, work out the number of different 3-digit numbers that can be set for the combination lock. Okay, so what are our key information? There are 3 dials on the combination lock. Each dial can be set to 1, 2, 3, 4, 5, and I've forgotten to highlight 3 dials. The 3-digit number 553 is one way the dials can be set, as shown in the diagram. So that's just an example. I don't think I need to highlight anything from here. So there are 3 dials. So I've got my first number, my second number, and my third number. Okay. You can see this question is slightly different from what we've done previously. But again, the process is the same. So what can go on my first box? Each dial can be set to one of the numbers, 1, 2, 3, 4, 5. So there are 5 numbers here. So if there are 5 numbers, I can have 5 here. So the first number can be 5, 1 of 5, any of these 5. The second one can also be any of these 5, 1, 2, 3, 4, 5, and the third number. And so we multiply this out. 5 times 5 is 25. 25 times 5. You can't do that in your head. You can add it up 5 times because it's a non-calculator paper. 1, 2, 3, 4, 5 times. And that gives us 125. Okay, 5, 10, 15, 20, 25. Carry the 2, 2, 4, 6, 8, 10, 12. So if you weren't able to do that in your head, you don't have to. You can just do working out. So that's the answer to the first one. And similar to previous questions, this is a method mark for having this and an accuracy mark here. So 2 marks for that. Now part B, it says, how many of the possible 3-digit numbers have 3 different digits? So the key to this is having 3 different digits. Okay, so we have a first number. We have a second number. We have a third number. Okay, now if we think about it, we can have 1, 2, 3, 4, 5. Okay, so there's 5 possibilities on the first one. If I choose one of them, how many do I have left? I've got 1, 2, 3, 4 that are left now. So then I've got 4 numbers here. If I cross off another one, how many do I have left now? So there's only 3 possible numbers left. So I'm doing 5 times 4 times 3. And so that, without a calculator, I can do 4 times 3 is 12. 5 times 12 gives me 60. And if you don't know your 12 times table, you can just split this up. 10 times 5, 2 times 5, and then add them together. 50 and 10 gives you 60. Okay, so my final answer is 60. And similar to before, having this working out is a method mark, and having 60 is our accuracy mark. Well done if you got 60. So again, the questions are now getting slightly harder. You have the same skill. We are multiplying numbers, but we just have to be a bit more careful. The numbers are changing on this occasion. Right, the 11th question. Okay, so this is worth 3 marks. So this is slightly harder than previous questions from what we started, question 1 and 2. Okay. Press pause and have a go. When you're ready, press play for the answer. Okay, so we've got question 16. Zia has to set a 4-digit security passcode on her phone. Each digit of the passcode is a number from 1 to 9. She can use each number more than once. Zia tells her friend Amber that the first digit is a cube number, the second digit is a prime number, the third digit is greater than 6, the fourth digit is an odd number. The diagram shows one possible 4-digit passcode, so that's one possible one. Amber is going to have one attempt at guessing Zia's passcode. Work out the probability that Amber guesses Zia's passcode on the first attempt. Okay, so we've got lots of information going on here. So let's highlight the things. Zia has to set a 4-digit passcode. So that's the first thing I'm going to highlight. 4-digit security passcode on her phone. Each digit of the passcode is a number from 1 to 9. She can use each number more than once. Each number more than once. Okay, so that's important. Zia tells that the first digit is a cube number. So the first digit is a cube. The second digit is a prime number. The third digit is greater than 6. The fourth digit is an odd number. So we can go through all of these possibilities. So we've got passcode is a number from 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I've just written the numbers out just so that I can visualize it. I haven't read the question fully or highlighted in. The diagram shows one possible answer. Amber is going to have one attempt at Zia's passcode. Work out the probability that Amber guesses Zia's passcode on the first attempt. Okay, so I've got my numbers 1 to 9, and there are 4-digit passcode. So I'm going to have 4 numbers. 1, 2, 3, 4 numbers. And the product rule for counting, I'm always multiplying. The first digit is a cube number. So cube number, 1 times 1 times 1 gives me 1. So I've got 1 there. I've got 2 times 2 times 2 gives me 8. It's a paper 3, so a calculator is allowed. I can also do 3 cubed, which is 27, but 27 is not on the list. So I've got 2 possible answers. So for my first box, I've got 2. The second digit is a prime number. So the prime numbers is not 1. That's a classic mistake people make. 2 is a prime number. 3, 4 is not. 5 is. 6 is not. 7 is. 8 is not. 9 is not. So 1, 2, 3, 4 digits there. So that's 4. The third digit is greater than 6. So greater than 6, 7, 8, 9. 7, 8, 9. So that's 3 numbers. The fourth digit is an odd number. So what are the odd numbers there? 1, 3, 5, 7, 9. 1, 2, 3, 4, 5 numbers there. So that is my possible digits. So what's my total number of combinations there? I can put this into my calculator. I've got 2 times 4 times 3 times 5. That gives me 120. Okay, now it's a probability. So 120 is my denominator. And work out the probability. She has 1 attempt. So 1 out of 120 is my final answer. All right, so hopefully you got that right. Where are the method marks from this one? So there's a method mark for identifying the number of options, or identifying two of these number of options. There's another mark for the, it's a process mark to multiply all four options, and three of the four options have to be correct. So as long as you've got three of these four, and then for the accuracy mark at the end. So that is it. We are now on to our last question. Thank you for liking the video if you are still here. Really appreciate your time, and hopefully you are benefiting. You can share this video with your friends. Here is our last question for today, question 12 of 12. This is worth 3 marks. Press pause, have a go. When you're ready, you can press play for the answer. This is from paper 2, November 2017, so we are allowed to use a calculator. Tracy is going to choose a main course and a dessert in a cafe. She can choose from 8 main courses and 7 desserts. Tracy says that to work out the number of different ways of choosing a main course and a dessert, you add 8 and 7. Is Tracy correct? You must give a reason for your answer. So you can see from our previous working out, we never add, we are always multiplying. So you can have Tracy is going to choose a main course and a dessert, 8 main and 7. And so work out the different number of ways. So if we look at this, our working out should be main course times dessert. So that's 8 times 7, which is 56. So is Tracy correct? No, Tracy is wrong. You must give a reason for your answer. 8 times 7. That's enough. Okay. The next question, next part. So part B, press pause and have a go. 12 teams play in a competition. Each team plays each other team exactly once. Work out the total number of games played. Okay, so you can see here you've got 12 teams, and they're going to play each other. So if you have 12 on the first occasion, you're not going to multiply by 12, you're going to multiply by 11, because there are, if you're one of the teams, there are 11 other teams. So we're going to do 12 times 11. Now you might think we multiply, but you're playing exactly once. If you think about it, if you have 2 teams, how many times are they playing? If you have 2 teams, let's call them A and B, how many times are you playing them? If they play, you can have A times B, or you can have B times A. But we're told that they are playing exactly once. So what we're doing is we can 12 times, if you had 2 teams, if you like, A times B, B times A, you would do 2 times 2, but they're only playing once. Because they're playing once, we have to divide by 2. Okay, so that's the confusing part, because they're only playing once. Okay, so A times B, B times A, but this is 2 different games. You can't have them, it can only be once. So that's why we divide by 2. So we're going to divide by 2. 12 times 11 divided by 2. Well, that's the confusing part. Okay. Not sure why I wrote 2 here. It should be 2 times 1. So if we do 12 times 11, then we divide by 2, gives us 66. So that is the key part to this question, 66, because they are only playing exactly once because of that. All right, so hope you enjoyed this video, and I'll see you at the next one. Take care. Bye-bye.